Hi everyone, in this video I'm going to talk about the comparison between discrete random variables and continuous random variable. So the topic is discrete versus continuous random variable. Okay, so first, discrete random variable. Okay, so by definition, it's a list of possible values for the random variable. Outcomes. Okay, and so all the possible outcomes are within a range of values. Okay, so I like to see or interpret discrete random variables to be if you are in an interval or a range of possible values, and then the total number of possible outcomes, values within an interval is a fixed number. So you cannot create another outcome in between two outcomes. So in our example, in the previous video, how many classes your friend can take next semester is 1, 0, 1, 2, 3, 4, 5, right? So in this interval, in this range, you have 6 possible outcomes, and you cannot create another one in between them, right? So you cannot have 2.5 classes, right? That's not possible. So these outcomes are discrete. Where compared to continuous random variables, continuous random variables. Okay, continuous random variables, the definition is any values in an interval can be random, can be the random variable outcomes, right? What it means, right? So if we're interested in the weight of this class, you can have 80 pounds to 160 pounds, right? And this is an interval and this is a range. Is it possible to have, say, 80 point? So is it possible to have 90.6 pounds? Yes, that's possible, right? And then is it possible to have 101 pounds? Yeah, that's possible. So any values in between 80 and 160 is possible, right? You can even say it's possible to have 96 pounds, and in between, you have another outcome. So you have infinitely many possible outcomes, where in the discrete case, you cannot create another one in this interval or between these outcomes. So that give us a way to kind of differentiate between the two, right? The way I like to differentiate or make a decision of which type of random variable you are in is try to pick two outcomes, right? Two outcomes you already have, and take a value in between them. If the value you created between the two outcomes, if it's a possible outcome, then this set of variables are continuous. If not, then they're discrete, right? In this case, say 2 and 3, is it possible to have 2.5? No, so it's discrete. say in this case you have, let's imagine 96.2 and 92.6 and 93.6. You know, these two are possible outcomes. Can you have one in between them? Yeah, of course, right? 93. It's possible, right? So in this case, you are looking at continuous variable because you can create as many possible outcomes as you want. Okay. Next, I want to talk about how you would calculate mean and variance for continuous random variable. Okay, so in our previous video, we talked about the case with how many classes your friend is going to take next semester, where when we talk about the possible outcomes, we kind of attach probability to each possible outcome. But in continuous variable, since you have infinity many possible outcomes, you kind of cannot attach probability to each single outcome. So instead, for a continuous variable, continuous random variable, we have what we call continuous distribution. Continuous distribution. Continuous distribution. Now let me just plot one to show you. Say you have a normal distribution, and then in the horizontal axis, these are all the possible values for your outcome, where the height, the vertical, the y value, it's the function of probability. So the f of x is the probability of this possible outcome, right? So this is what we call the probability density function, or PDF, right? PDF tells you, so if you give me a value, I'll tell you the height, you know, so what is the probability of this tiny range of that event happens, you know, so say this is, let me create a 10, you know, very random, so this is say 0.2, you know, 20% of this 10 will happen. Okay, good. We're gonna use this concept here, but let's talk about the formula for calculation for the mean. Okay. Mean for continuous random variable. Okay, cool. So let's see if this one works, right? So we had this formula, or equals to mu, and this equals to summation xi times the probability of x equals xi. So this is the formula that we used in our previous video, which is for discrete random variable. So will this work in this case? The answer is no. Why not? Because we have infinitely many outcomes, right? So with infinitely many outcomes, that we cannot take each single one and then multiply its probability and sum them up. It's just not possible. So this formula will not work. So in this case, for the continuous random variable, we have to use the integration method. Integration method. Okay, so integration method, where we're gonna say mu equals to expected value of x equals to, you're gonna take the integral, you sum up all the probability of each single value x, and then you're going to evaluate at the probability of x dx. Okay, so the probability of x at each single value is just the probability density function, which is your PDF, right? So you're going to take each single value times the PDF, and then you're going to take the integral. Okay, cool. So let's do an example to show you. Okay, so example. This is our x, and this is our PDF. So the possible outcomes in this case is range from 2 to 6. Let me do a triangle here. And then this one is 0.5. Okay, 0.5. This is the area we're looking at, right? So any value in between 2 and 6 is a possible outcome in this case. And then the height for each single value is the PDF. And then first thing we need to do, usually it'll be given a problem, it's the PDF. The PDF formula or function, PDF function. Okay, in this case, it's y equals to 1 over 8 x minus 1/4, and this is our PDF. Okay, so that's the formula for the PDF here. So next, we're gonna use this formula to calculate the mean here. Okay, so yeah, let me also erase this. So mu goes to expected of x goes to the integral of x and dx. Okay. Okay, then in this case, it equals to, the range is from 2 to 6. 2 to 6. And then x, right? X is just the value itself, so this is x. And then the PDF function equals to 1/8 x minus 1/4. So that's negative x minus 1/4, and then dx. And we're going to solve this integral here. So that's equals to 2 to 6 negative square minus 1/4 of x dx. This equals to 1 over 24. 1 over 24, and then cube minus 1/8 x squared, and then it's from 2 to 6, and that's going to give us 9 minus 9 over 2 minus 1/3 plus 1/2, and this equals to 14 over 3. Okay, and this is our mean here for this continuous random variable. Next, we want to solve for the variance. Variance, so sigma squared. So the formula we're going to use is expected value of x squared minus mu squared. Okay, so in this case, I decided to use this formula because we already calculated it for this mean here. So we can just square it, the result we got, and this equals to expected value x squared minus expected x squared, and and this equals 2. So now, instead of x here, right, we're looking at the integral of x. Now we're looking at the integral of x squared. In this case, it's equals to x squared property of x dx minus this value we got is 14 over 3 squared. And let me plug in the formula here. 2 to 6 x squared over ax minus 1/4 dx. There is a minus 196 divided by 9. Okay, we continue. This goes to 2 to 6, 1/8 x cubed minus 1/4 x squared dx minus 196 over 9. You continue to this side. And then this equals to 1 over 32 x to the 4, and then minus 1 over 12 x cubed from 2 to 6 is minus 196 divided by 9, and that's equals to 81 divided by 2 minus 18 minus 1/2 plus 2 cubed minus 196 over 9. And the final result in this case will be 8 over 9. And this is the variance for this continuous random variable. And then for the standard deviation, again, you are just going to take a square root. So for standard deviation, sigma, you just take the square root, 8 over 9. Okay? Good. So in this video, we talked about the comparison between discrete and continuous variable and the method that you're going to calculate for the mean, the variance, and the standard deviation for continuous random variable. Thank you for watching. I'll see you in the next video.